Problem 3, watch the video below and tell me which trust member failed first that caused the whole bridge to fail. So now let's watch the video here. So now you can see they are installing the blister over here, probably detensioning the member over here, and then it collapsed. It happened so quick. Let's see if we have any slow motion. So it happened so fast over here, but you can see that the collapse is started around this area, So if you take a look on the report, you can see that the collapse is started on the member 11 and member number 12 over here. That caused the collapse of the bridge. Problem 4, let's go back to the report here and look on the page 108. What is the capacity and the actual shear force of the truss member 11 and 12? Oh, sorry, this one is the joist between 11 and 12. This is the joist 11 and 12. You can see that. As you can see here in the page 108, you can see that if you read the whole thing here, you can see that the capacity is the design value for the joist is 1086 kips. This is the capacity or the design value. However, the actual force that applied to the joist is 1579 kips. So you can see that the demand was 45% higher than available capacity. So which means that this one is under designed by 45%. That's why the bridge is collapsed. And then on the next question, they ask which company caused the structural failure. You can see that FIC instructed retensioning the PT bar and many things over here. But generally, these pages over here indicate that FIC is the one that under design the bridge, especially for the joist between the truss member 11 and truss member 12. So in summary, let's summarize this one. You can see the capacity is the one we just discussed, that is 1086 kips. The actual shear force is 1579 kips, and this one is under design by 45%. Which company caused the structural failure? That is FIC. Next question, problem 5. Using the article, please answer the following question. When was the cracks seen by whom? So if you look on the article here, the crack is identified on the February 26th of the 18 by PPA. That is the inspector. That is third-party inspector. And next question, when do GC and engineer company know about the crack? So go back to the article here. You can see that on February 28th, the photo is sent to MCM. So they sent to the general contractor and also FIC as well. So then notice there's a crack on the 26th, and they wait for 2 days to send this one to MCM and fix. Next question, what fix says about the crack? So as you can see on the March 7, so they wait for more than a week, and they reply back over here. Photo 1, no structural concern. So you see that they send a crack. Photo 1 over here, there's some crack. Okay, and another crack on photo 2 as well. Another crack on photo 3. Photo 4 crack. Photo 5 crack. So you see that there's a lot of crack in the bridge. And then FIC, they do some calculation and they say photo 1, no structural concern. Photo 2, no structural concern. 3, 4, 5, they say that no anything over here, but generally they would say that there is no concern. Next question is when was the second crack seen by whom? As you can see here, if you look on the March 10, and on March 10, the truss was moved into the final position, so which means in the third phase of the construction, they moved the bridge into the final position. And then VSL, you remember VSL is the one that do the post tensioning. So you see here, so you have VSL, where is VSL? VSL here, that's a post tensioning subcontractor, and they report directly to MCM. And then VSL, they found a crack over here, and they send the photo to their supervisor. They say that it cracked like hell. So which means that the subcontractor found there's a crack, and they think that is a big problem, and they say they update that to the supervisor. And then what next? And then when do GC, what do GC do when they see the second crack, and what does FIC reply? So let's continue with that. So you see MCM over here send some employees to take the photo of the crack. You see it look very bad over here. It's a serious problem. You see this one is a big crack. And they email to FIC. So what they do is that they send some employees over there, take a photo of the crack, and then they also send the photo to FIC as well. And the MCM representative concern, also they express some concern. Some of the crack are larger, rather than large, and of the concern, and your immediate attention response is required. And then on the next day, FIC review the photo, and they instruct to put additional plastic shim similar to existing shim on, but generally they say that put some plastic shim over there. And what they say here is that they say they ask the MCM to retensioning the 2 PT bar, okay, to be which previously has been distressed. So they see the crack over here after they distress the PT. You know that the PT is the one that used only in the transportation. That is the purpose of the PT in the truss. And after the bridge is placed in the position over here, it will be distressed. However, the FIC company, they ask the MCM to retension. the 2 PT bar over here. So you see a lot of crack, and this one is very big. You see that one is very serious. You see that a big crack over here, a lot of crack. Next one, there is the subcontractor VSL concerned about the crack, and what did they require fix? What did fix says? So you can see here, VSL. So VSL, who were concerned about a crack, wanted FIC to analyze them to determine if epoxy could be used to measure of as a measure of repair, and ask MCM if the crack should be repaired before retensioning the PT for the member 11. So you see that even VSL over here, they are just a subcontractor, but they see this is a serious problem. So they ask the FIC company if we should put any epoxy over here to seal the crack before we do the retensioning, because they feel that there is a safety issue over here. And then you see that on the and then on the day they have the accident, which is March 15 over here, they send two structural engineer to the site to inspect the crack, and they do some inspection, and they say that the crack do not present any safety concern per FIC evaluation, and they say temporary loading duration, many things over here, but generally they say that it is okay, just go ahead and continue with the construction, no problem or no concern is in the construction. And then on the afternoon it's collapsed. So you see that it's collapsed, and it collapsed during the VSL worker doing the retensioning for the member 11 over here. It collapsed. That is also the answer for question I over here as well. So let's discuss over here a little bit. So you see that the there's many people warning about a crack many times, from all the way from February to the March, and they send the message to MCM. MCM cannot decide anything, and they send the message to FIC, even though FIC is the one designed for the bridge. However, this one is design, build, delivery method, so which means that MCM is the one that take all responsibility. If a better action by MCM is that they can pause the project, and then they can ask for a third party doing some analysis or doing some calculation before they resume the construction. However, they didn't do that. They just rely mainly on the analysis of FIC, and FIC make error, and then the project collapse. So now let's check problem 6 over here. That's the last problem. Read the article 1 and article 2 and discuss what is the consequences to the GC company. For this problem, I'm gonna let you guys read that by yourself, but generally I can summarize that GC is the MCM over here, is the one take the main responsibility, and they have to pay more than around like $100 million, and that result in the bankrupt of the company. However, for the FIC, that is the design company, the main architect or the main engineer, his license being revoked. However, beyond that, nothing else happened to the engineer company. So you see that because this one is the design build delivery method. That's why the GC receive all the consequences, mainly all the consequences. If this one is design bid build, then the engineer maybe the engineer will be the one take all responsibility because there is an error in the design. However, this one is design build, so GC is we take the highest responsibility. What can you do to avoid the accident? So if you are the GC, what can you do to avoid the accident? I will let you think a little bit about that. I recommend you to pause the video and think a little bit about that before I share my opinion. All right, so after you think a little bit about that, I'll share here my opinion. If I work for the GC, what I will do is that I will pause the construction when I see a lot of concern like that. And then I will have a face-to-face meeting with the structural engineer of FIG, and I will ask them multiple questions. Beyond that, I also hire a third party, maybe another structural company, to analyze the crack to see if FIG do the good job in calculating or designing the bridge or not. Okay, so the first thing I will do is that I will pause the construction. Second thing I will do is that I will hire a third party to check the design until I need to make sure that all of the calculations are correct before I resume the construction. Why? Because the GC over here, we are the GC, and in design build we take the highest responsibility for the project, so that we need to do that. What might be changed if this is design bid build? As I discussed previously, the change of this one is that the engineer maybe will be the one take the major responsibility for this accident.